This water fuel cell technology memoir or notes that I found here from Stanley Meyer, as you can see here, has some very interesting information here. I want to point something out to you guys. Right here it says, a minute amount of voltage, a potential energy and not energy consumption, gives the atoms the impetus to break away from one another in a strictly physical process. Now he says a minute amount of voltage. Now a lot of people say that, you need thousands of volts to disassociate the water molecule and yada yada yada. Although Stan does talk about thousands of volts in some of his apparatuses, the electrical polarization process specifically, as stated here, requires a minute amount of voltage. That's when I'm putting 118 volts across the cells. I'm only putting somewhere between 4 and 6 volts per concentric tube. If I've got 5 volts on each individual tube, that's only positive 2.5 volts and negative 2.5 volts applied simultaneously, because we are applying equal opposite polarity, because the water molecule is a dipole molecule. And here again, all that was needed was the creation of 2 electrical voltage zones opposite in electrical polarity. I harp about this all the time. Equal opposite polarity. That is the secret sauce, you guys. This is Stan's Revenge. I go to fire up the cell today, and less than 1 amp, I'm getting 120 volts at the cell at 123 milliamps with that EOP waveform, but I am not getting production as I should. Now I got nothing. I think we finally got it working. We have maybe a connection problem with one of these cells here internally, perhaps. I've got this thing all wired up, different config. And if you can't see, I removed my diodes. There are no cell diodes presently. We're at 126 volts at the cell, just over 1 amp, pushing 7.6 amps in at 32 volts. Definite production appropriately for that. We almost have a balanced waveform, but we still have more negative potential here. I'm going to actually zoom in on that. I'm going to pause that. I'm going to spare your eardrums here. Presently, we have this entire wrap bifilar connected to the Inductor A position. On the positive side, you could say. Diode is in our standard position. Again, all these coils are just linked up, or it's just one continuous bifilar wrap. And I still don't have enough inductance to balance this thing. Now, with these diodes removed, that drastically changes what is necessary for the balancing of the inductor. The diodes are almost a cheat code to be able to use less inductance over here, less inductance on the wrap, because previously with the cell diodes in place, we were only using that much of this bifilar inductor on that A spot right there. Bam. Now we have the entire thing without the cell diodes, and we have drastically different waveform here. We do have that negative dipping back over that arbitrary 0 volt line, which I don't like. But we may want to wrap this thing with more bifilar wires to try to balance this without the diodes to see what that does. Because we are definitely like in this configuration, obviously, because we have more winds on the inductor. We are able to achieve a maximum voltage of 127, 128 volts. Pretty impressive. We definitely get the production here. So I will demonstrate. 1, 2, 3, go. Definite appropriate production. And we're just 400 milliamps over what we were previously, generating a much higher voltage at the cell. Here again, if I can get these balanced, that very well may cut amperage down to a level that will be very, very impressive, because we will have a even higher voltage level at a similar or lower amperage, which means more gas, less energy. You know, from this point, anything we achieve over this is essentially overcoming or outdoing traditional DC electrolysis. Anything from here is just efficiency beyond that. So, you know, this has so much potential to it right now. Like, I'm at this cusp of what this apparatus is and is capable of. So I guess for right now, my findings are that even though diodes are great for achieving the equal opposite polarity, that does not necessarily mean that inductance, resistance values are perfectly balanced for optimal production. It just means it gets you there, as again, kind of like a cheat code to say it doesn't really matter what this is, the diodes are going to rectify it and give you EOP on much lighter constraints than what it would be without the cell diodes going in and out of the cell. It's a pretty interesting finding. And since I got tons of this scrap I pulled from it, I think I'm just liable to wind that up right now. What do you guys think? Here we go. It's going to be a butcher of a job, but it's definitely possible, and it shouldn't take that many winds given the circumstances. We're pretty close. You guys want another montage? Yeah, I thought so. Let's go.
This is Stan's Revenge.
So I've tried a whole number of setups here, and I really wasn't able to get anything spectacular. We got up to 127 volts. We were consuming more amperage, 7, 8 amps. So typical amperage. I've been blowing these diodes with this new configuration, and just not really conclusive on anything really with this different type of setup. We'll just have to keep at it here. Just to a quick point here, I wanted to point out this multimeter here is set to AC/DC for the amperage. The multimeter here is for voltage. It's set to DC presently. As you can see, we're getting appropriate voltages measured on there in DC mode, as the oscilloscope here shows as well. Now, if we switch this to alternating current, it will not display any alternating current because there is in fact no alternating current. What we see here more so, I'm going to pause this, is opposing voltage potential, but it's practically DC at the cell. We are establishing essentially static voltage fields at the cell in opposite polarity. There's no alternating current. We're not going from negative to positive, and there's no AC here. It is strictly DC pulsing, but more so, it's just, with the exception of the pulse off time, it is strictly a DC static voltage field that is at the cells, which is what I'm measuring here at DC mode. There is no AC whatsoever. But today we're getting some even higher voltages. Look at that. So, interesting configuration of essentially taking one of the secondaries coils, using it as inductor A, putting the diode between the two secondary coils for the secondary plus the inductor, and then using my balancing inductor here as inductor B, as the variable inductor. You can see we do not have equal opposite, but you do see we are achieving the 118 volts. Let me bump it up here. As previously seen, about 118 volts there. But I'm achieving it at 5 amps at 24 volts. That brings my amp consumption down to 124 watts of input power. Times my multiplier here, 3.17, that brings us down. That's under 400 watts now. Guys, under 400 watts. We are very much at or below traditional DC electrolysis with just another minor configuration change. I wonder what happens when we balance these waveforms out.
This is Stan's Revenge.